Here we go. All right, so we are still going to solve quadratic equations. The practice page that we were just doing, you saw discriminants that were perfect squares, right? Or non-perfect squares, but they were all positive numbers. Yes? Because we know how to deal with numbers. I have no idea how to deal with that. So in the past, like in Algebra 1, you would have been told if you ever get a negative number under a square root sign, you would have been told that there were just no solutions because we didn't know how to deal with it. I had you guys type it into the calculator earlier. It gave you that error message. Well, now, the imaginary number that we call I. It's just this itty bitty little italicized italics, you know, that's what it is. It's just a little I. But the letter I represents the square root of -1. So if we had negative numbers under here, we can just get rid of the negative sign by bringing out the letter I. The formula for this will all contain the letter I because all of the discriminants are going to be negatives. Okay, that's the only difference. You will have a letter I in your answer. Down here, this is just review. We've been solving for those are called your x-intercepts. We talked about that yesterday, I think. And then there are other names for them, like you can say solutions, you can say find the x-intercepts. You might see the word roots. I think we've already seen roots. Yeah, we wrote it today. It was on the first lesson. And we also call them zeros. All of those terms all mean the same thing. Okay, so if they say solve a quadratic, it doesn't matter which term they're using. We're doing the same thing every time. We're looking to see where our parabola would cross the x-axis. All right, turn the page. Here's more of what you guys saw in the first lesson. This one would have two solutions, two real solutions because it crosses twice. This one would have one real. I'm going to add in the word real here. But then this one, I told you I don't want you, I want you saying two imaginary. What is this whole letter I? Down here at the bottom, I represents the square root of -1. So for instance, please watch. Radical, I saw -4. This is what I would do. It could be -1 times 4, right? Isn't it -1 times 4 -4? Well, we know -1 is I. So to get rid of this negative sign, I would bring out a 4. So I would bring out a 2. And my answer would be 2i. If I had asked you what the square root of 2, so what is the only difference between a positive and a negative? Look at the answer. The negatives under your radical, the only difference is that you should have a letter I in your final answer. That's it. So here are 3 more examples down here at the bottom. What's the square root of 81? This negative sign, see the letter I next to it? It's just 9i instead of 9. It's like having the square root of -1 times the square root of 81. So the square root of 81 is 9, and the square root of -1 just attaches the letter I to it. That's it. That's the only thing that changes. And the only time you'll see I is if there are no I's, because all of your numbers under the radical were positive. This second lesson, the only difference is we're going to have negatives under the makes is you'll have an I in your answer. Now, the square root of 121 is 11. It's a perfect square. And then we brought the negative. We dealt with. And then do you guys know what the square root of 5 is? We don't, right? So this is like having the square root of negative. We know this becomes the letter I, so that gets to come out of the radical. But since we don't know what the square root of 5 is, and then when you're ready, turn the page. Okay, so let's start with this one down here. I'm going to go in a different order because I just like to. Perfect square, so we get to put 6, and then to get rid of that negative sign, put an I on it. Ta-da, done. Now let's go over here to this one. Do you guys know what the square root of 2 is? No, so the 2 has to stay under, but for negative, put an I in front of the radical. It's really that simple. Oh, this one. 12 is not a perfect square. Can 12 break down to a factor tree where we would have a perfect square? Which one? 3 and 4. Yep. 4 is the perfect square. I mean, it would break down to 2 and 6, but 2 is not 4. Okay, so watch. Square root of 4 comes out, which is 2. What else comes out? The I to get rid of the negative. And then what number stays under? 3. Yep, that's it. So we show you this because we're about to do the entire quadratic formula again, and you guys are going to see numbers like this under the radical. The only thing that's going to change and get 2 radical 3, but we're going to have to put the letter I there to deal with the negative sign. Okay? Are you ready? 2. We're only doing 2 of them. Okay, so go down here. Is that one set equal to 0? Yes. So that one is identify A, B, and C. What's A, B, 6, -1, and 3. Ooh, that's not. So set up your quadratic. Well, you don't have to set it up. I'm just setting it up. Plug in our numbers. We're going to do our substitution, and then we'll solve just like we were doing before. Opposite of B. B. C. A. There you go. Okay. And then just like we did earlier, leave the 1 alone. And then we shorten up our radical so that way you guys can figure out what that discriminant is. See you later. And then we would also do 2 times 6. So I'm going to put a 12 on the bottom. Type away. 24, 72, 71, negative 71. Forgot the negative sign. Whichever one I feel like it. I mean, I did these to get. I like to challenge myself every once in a while, even though I'm off my game. I probably shouldn't try to do the math in my head today. Well, how old are you? I've been doing it. I love math. It's the only thing I'm good at. All right, you guys get negative 71? Anybody? Okay, so this is all you do. Look at your factor sheet. Look at the row of 71. Does 71 break down at all? Here's the thing. If this were positive 71, I would literally be done. There would be nothing I could do because 71 wouldn't break down. However, since it's negative 71, there's only one thing I have to do. Doing what? Put the I right in front of the radical and turn that 71 back to a positive. That is the only. Now again, if that had been a number that was like a perfect square, like 81, we would have made this a 9i and the radical would be gone. If it were something like 52, but this one, it doesn't get any easier than this one. Like this is as easy as it gets because you didn't have to reduce, you didn't have to make a factor tree. All you had to do was get rid of that negative sign. Yep. So are we good so far? Make sure you extend this fraction. It needs to be, yep. Because the way you had it, it looked like only this was being divided by 12. Okay, turn the page. This is the last one we're doing together. So you might as well just assume we're going to have to do pretty much everything on this one. We're going to move factor tree, probably going to have to reduce. And there's going to be an I. This is the best. All right, so I want my x squared term to stay positive, which means I need to move these two, right? Will either don't pair up with anything, correct? So my 8x is going to become negative, and my negative 8 will become positive. So these three terms right here are on the left side. They don't pair up, so I'm just going to write minus 8x plus 8 equals 0. So A is and C. On your notes, we always use the letter X, but pay attention on your paper because they're like different letters. So you're not always going to put X equals. It might be M equals, N equals. All right, here we go. The plug-in part. Opposite of b goes to positive 8. And then the regular b is the one that goes here that we square, which is negative 8. Which is 6. And next to the a is c, which is 8. Then on the bottom, 2 times a, which is 6. So there is your substitution step. And then shorten the calculator. And I went ahead and multiplied out the bottom. Sounds about right. 48, 32. -64. Yep, negative 128. Okay, so now if all of you right now could get rid of this negative sign by doing what? Just putting an I right in front of that radical, and it turns it back into a positive 128. You know, if nothing else, do that. You know, get rid of. Now you're looking at this, and we need to know, is 128 a perfect square? No. Well, you can check it on your calculator, right? Put a decimal. So let's make a look. 128, people. Definitely not divisible by 100. It is. It's 64 times 2. So you do 64 times 64. So 8 comes out and 2 stays in. That's 128 right there with 8 radical 2. Okay, so I would write x equals, taking this out, we've got to leave the I there. And I always put, like I would put the 8 first, then the I. 8I, radical 12. That would be your final answer if things didn't reduce. So the 8, and the 12 are the only ones that will reduce. Yep, and 12 on the bottom. Okay, so now you're ready for what I'm about to do. Are all, they can be divided by 2 or 4, so you want to reduce them by the 4. So if you divide 8 by 4, 2. Now you can't touch this 2 that's under the radical, so that stays a 2. And then what's 12 divided by 4? That's your final answer. And if this had been on your first practice positive 128, you would have literally ended up with this exact same answer, except that I wouldn't be there. But you would have had to do all those same steps. It's really no different than what we did the first part of class, other than you will have I's in your answer because all of your numbers under your